Hello, my name is Stephen Reynolds. In this presentation, I'll be elaborating on the relationships between brain structure and function in the memory and communication. First, communication starts with learning and memory development, involving the brain system and process. As Carlson and Brickett in 2021 pointed out, when humans communicate, they require perception about past and current events to be processed in their memory. Perception of memories can occur in the posterior part of the cerebral hemisphere, including the optical, temporal, the partial lobes, and the prefrontal cortex. Perpetual learning is a sensory process, while relational learning in the memory of the subcortical process. The sensory process in perception learning occurs via sensory systems such as auditory and visual systems. The environment offers reinforcement and conditions for the individual to be exposed to stimuli, learn, and memorize information. Hence, the auditory and visual association cortex receives environmental stimuli and transmits them to the interstitial cortex via the neutral circuit. Such stimulation changes the auditory and visual association cortex structure to enhance perceptual learning. Carlson and Brickett, 2021. Also, the interstitial cortex sends input to the posterior prefrontal cortex for perception and the temporal cortex for the recognition. For instance, when the extrastriate cortex is exposed to sensory stimuli, it changes synaptic connection and establishes a new neuron circuit that becomes active when the same triggers occur again. The possibility of retaining such sensory memory occurs in the sensory association cortex. The sensory memory consolidation occurs via the subcortical process for short-term and long-term memory within the hippocampal formation and the other brain structures such as the basal ganglia and the amygdala. Even though the neutral circuit involved in perception learning is located in the sensory association cortex, short-term perception memory involves the prefrontal cortex function. The prefrontal cortex provides inputs to the ventral terminal area, which manipulates the organized information to be remembered, device retrieval strategy, and monitors the outcome of the process. Also, Carlson and Brickett, 2021, also noted that the basal ganglia connected with the prefrontal cortex filter irrelevant information and maintain the relevant information from sensory memory for storage and future recognition. However, long-term memory formation is enhanced with the hippocampal formation. It is compromised and degraded in the subclavian, enhancing the relational learning and memory. The hippocampal formation receives input from the cortex, which terminates the CA1 and CA3, and the gyrus from the amygdala, limbic cortex, and the neural cortex in the medial temporal lobe. Carlson and Brickett, 2021. It also receives input from subcortical regions through the fornix, which selects the moderates and the hypocortical function. The information received by the hippocampal formation from sensory association cortex and subcortical regions is processed and consolidated in episodic and cinematic learning memory. These memories are stored in the anterior lobe and the faculty recalling past events in a proper sequence in communication. Also, declarative memory enables the recognition in faces, locations, sounds, and voices from past to present encounters. However, in the neurological level, communication dependent upon memory occurs based on the neuron-to-neuron communication via electrical and chemical signals. According to Della Bell and D. Miguel, 2018, neuron communication occurs at the synapse. Like terminal buttons in the prefrontal cortex, connect with the extrastriate cortex, secrete, glutamate, and the other neuron transmitting like dopamine. These neuron transmitters cause presynaptic changes, Calcium activated nitrous oxide sensitive in severe brain regions like the hypercomber dental gyrus field of CA1 and CA2 causes changes to the enhanced communication to the postsynaptic membrane by changing the size and shape of the deteriorate spine to enhance synaptic transmission in the brain neural. Thus, brain structural, especially posterior and the cerebral hemisphere, play a vital role in the memory and communication. It enables learning from the sensory stimuli and recalling the events. Thank you very much for your time. If there are any questions, I will take them now.